Okay, good morning, everybody. Praise be to the Lord. We're going to continue with our classes today, and now is the opportunity to have science. Okay, so today the topic in science will be erosion and deposition. To continue with the unit is almost finished. Okay, so we are going. I will say it if tomorrow we are going to have classes in the platform or we are going to have classes virtual or we don't have classes of science tomorrow. I will say it, don't worry. Okay, so um I will share some slideshows because we're going to read on the book and we're going to work in some exercises from the book. Okay, I will share some slideshows that is start to comprehend. Even I will share a video, okay, for you to see what are we going to talk about in this topic. So let's see. Let's see. Okay, everybody can see the screen? Okay. Erosion and deposition. That is the topic for this week in science and for today. Now, let's see a question. What is an erosion? Erosion is the movement of materials from a place called erosion. That is erosion. The gravity is the main force causing erosion. In landslide, gravity quickly pulls rocks and soil downhill. Okay. Now, what is deposition? Deposition is the process of laying down materials such as rocks and soil. These sediments can be deposited in different places by wind or flowing water. With erosion and deposition, okay, let's see and ask this question. Why don't rivers travel in straight lines? Do you ask this? Why rivers don't travel in straight lines? They always make curves in any place, like we see in the pictures. They have to avoid obstacles as they flow downhill. People have altered river courses over time. Erosion and deposition can change the shape of a river. What do you think erosion and deposition are? Watch this video that shows what happens to minerals over time. Okay, let's watch the video first. Okay, just wait, we're going to start to see it. goodness. Okay, don't worry. We're going to share from another place. Okay, just give me a minute. Okay. And let's see. Let's see. Just give me a minute, people. I'm still having problems with. Okay. Okay, let's see. Can you see the screen? Yes? Yes or no? Yes.
Talk about stream erosion and stream deposition. The exclusivity here, the reason we're really looking at this particular type of erosional agent is because it creates an erosional system. An erosional system means that there's erosion and deposition happening throughout this mechanism, this act of nature. So water flowing downhill through a channel is called a stream. Now, obviously, that can also be a river, a creek, a brook. It depends on how big it is, really. But the general anatomy of a stream looks something like this. You have stream banks on either side. Those are the sides of the river. Any curve in the river is actually called a meander. And the base, the actual floor, the bottom of the river is called the stream bed. And if I were to look at all of the tributaries, those are the individual river systems that kind of feed into one major river, we call that a watershed. That's the entire area that contributes to a river. Let's use the Mississippi River, for example. The Mississippi River empties out to the Gulf of Mexico, and it runs through pretty much the entire length of the United States from north to south. There are many tributaries that feed into the Mississippi River, and when you take into account all those tributaries that feed in, that's a watershed, because it all kind of feeds into the same river that empties out into the Gulf of Mexico. So the stream itself, a river or stream, the water flowing in it is moving at a certain speed, and that speed is going to be dependent on really three different things. The discharge, how much water is actually being outputted, the slope, the degree of steepness of the ground it's covering, and the shape of the channel that it sits in. So just some general relationships here. If I were to look at the gradient and the speed of the stream, as I increase the gradient of the ground, the slope of the ground, I'm going to have a faster stream. If I were to look at the amount of water in a stream, the more water flowing in the stream, the faster that stream is going to move altogether. And then finally, if I compare a narrow channel, a narrow stream channel to a wider stream channel, the more wide this channel is, the slower it's going to travel. The water is going to actually be much slower in that wider stream bed. So a younger river system will have steeper gradients, faster speeds, rapids, and a lot more erosion than deposition, because the water's moving fast, it's cutting away and carrying away sediment, so you have a lot more erosion taking place. Older rivers have much more gradual slopes. They have wider channels, like you see in this picture, very slow movement overall, big meanders, big curves, and I'll show you that in a few more slides from now, and a lot more deposition than erosion, because you have slower moving water. As water slows down, it's going to drop off whatever it's carrying. So in a straight stream, the water is flowing the fastest in the center, close to the surface. The problem is, streams don't really flow straight for very long. There always seems to be a curve or a bend in a stream. And when a stream channel curves, the faster moving water is going to shift to the outside. So if we just follow the animation here, in this part of the stream, we have a straight part of the channel, so the water is fastest down the middle. But from C to D, I have a curve. So now my faster moving water is going to be forced to the outside of that curve. So that's my faster moving water. And then from E to F, my faster moving water is going to be pushed to the outside again, which makes it moving faster at F. Now the reason this has to happen is because water is trying to keep up. So if it's moving fastest in the middle when it's straight, when you have a curve, the inside of the curve has to move slower and the outside of the curve has to move faster. Same thing over here from E to F. Now it's reversed. The outside of the curve has to move faster to keep up with the inside of the curve, which has to move slower. So those of you who have run on a track before may know this already, that if you're running a race, the people on the inside have a much shorter distance than the people on the outside. So if you're running on the outer lane, you have to cover more ground than the person on the inside. This is the same mechanism going on with a stream when it goes around the bend. So tying this back into erosion and deposition, faster moving streams pick up and carry away sediment. That's erosion. When streams slow down, they will drop off some or all of the sediment they're carrying. That's deposition. So in our stream example, when a stream is slowing down, which is the inside of a curve, they'll deposit sediment. When a stream is speeding up on the outside of a curve to keep up, they'll do more erosion. So in a stream channel like this, I have an erosion and depositional system. So at A, because the stream is going faster, it's on the outside of a curve, more sediments are being picked up and carried away. There's a dominant erosional force because of the higher speed. On the opposite side, because the stream is slowing down to keep up with the higher speed at A, there's more deposition. It's deposition dominant. Now it reverses down at the bottom because C, we have the inside of the curve, there's more deposition. And then at D, that's the outside of the curve, there's more erosion. When we look at the stream bed, all right, if we were to take a cross section of our example and say, okay, from A to B, what would the actual shape of the stream channel look like? Right? We know that there's going to be more erosion at A and more deposition at B. What would that do to the stream channel itself? Just take a look at the three choices and select the best one. So if you chose choice 2, you'd be correct. The reason choice 2 is the best choice is because there's more erosion going on at A, so that's a much steeper channel, more steeper part of the channel, and there's more deposition going on closer to B, so you have a much more gradual rise of deposited material. All right, take a moment now to look at this example and choose which one, A or B, would erosion be more dominant over deposition. So in A, deposition is dominant because we have slower moving water. It's on the inside of the curve. You can even see it in the example, that beach, that sediment there is from deposition. And then at B, that's where erosion is more dominant because it's on the outside of the curve. The water has to travel faster to keep up with the inner part of that curve. Try this one. Which of the two locations would now deposition be more dominant over erosion? If you chose B, that's correct. Deposition is dominant because it's on the inside of the curve. Where A is, that's on the outside, and that's where erosion is dominant, because we have faster moving water on the outside of curves. Going further with this, due to erosion and deposition, meanders, these side-to-side bends, get wider over time. So they actually bend further away from each other. And if this continues, if erosion and deposition continue long enough, the meanders get so wide that they cut off themselves from the river itself. And they form these structures called Oxbow Lakes. If you think of an oxen, has that thing, that yoke around its neck, that's where they get the name from. So here are a couple of Oxbow Lakes, which were part of the river system. They were meanders, they were turns, they were bends in the river, but deposition closed them off because of the speed of the water from the rest of the river system. So streams also deposit sediments as they enter large bodies of water, like lakes, oceans, and other rivers. We talked about this with deposition. And as the water slows down, and as it enters into a larger body of water, the sediments are going to be deposited according to those characteristics we already discussed: size, shape, and density. In this example, you can see that it's organized by size: pebbles, sand, silt. What would X be? X would have to be whatever smaller than silt, which is clay. Now, this mechanism is called horizontal sorting. When sediments get deposited vertically, and they start to build up from biggest to smallest, we call that grid bedding. It's a vertical sort. Sorting is always a sign of water slowing down and depositing sediment. Now, over time, deposited sediment will enter into a large body of water and start to form a delta. Now, a delta looks, as you see in this diagram, from stage 1 to stage 3, it's a buildup of deposited material that over time becomes space for fertile ground. You can actually have soil, and then it can lead to new tracts of land. So a delta system, a river delta, is deposited material at the mouth or the end of a river system. So finally, just to kind of close the topic of erosion and deposition of streams, the erosional force of water is a constant abrasive force. You may not see it, you may not feel it, but when water is moving over very quickly over rocks, it's carrying little bits of sediment, and those sediment act like sandpaper, and they break down the rocks that they're flowing over. So in general, the rocks in fast-moving streams and rivers are going to be smooth. They're going to be rounded. The more rounded they are, the longer they've been exposed to the river. That's it for now, and thanks for watching.
Okay, people. In that video appear a little bit more what is deposition and what is an erosion. Okay, as we saw in the slideshows. Okay, I will share again the slideshows just to remember. Okay, just to remember. Okay, an erosion is is the movement of materials from place to place. That is an erosion. Also, the gravity is the main force causing erosion. Okay, Gravity helps to make erosion. In landslide, gravity quickly pulls rocks and soil downhill. Okay. Now, if you remember, and if you watch and pay attention to the video, the deposition is the process of laying down materials such as rocks and soil. These sediments can be deposited in different places by wind and flowing water. Okay. Now, is the way that I asked you earlier in the class. Why don't rivers travel in straight lines? Because they have to avoid obstacles as they flow downhill. People have altered rivers' course over time. Erosions and depositions can change the shape of a river. What do you think an erosion and deposition are? We already saw the video. As meanders grow, something in the water can erode away so much of the river's banks that two meanders will merge together. When this happens, the water will take this newer, shorter route and not travel around the previous course. Over time, the position of the river slope will block off the old part of the river, and an Oxbow Lake will form. Now, an Oxbow Lakes. The map and aerial photograph show the same part of the river trend. The river is this one here. Okay. Can you see the Oxbow Lake? Where do you think is the Oxbow Lake? As the river no longer supplies the lake with water, it's not shown on the map. It's supposed to be this one here is the Oxbow Lake. This one. How rivers change shape. Label your river diagram to show where erosion and deposition occur in the river. For example, if you have a map in your desk, or also if you see a map, okay, you can annotate the map to show where meanders and Oxbow Lakes are formed. Let's see what is about waterfalls. What will happen to the shape of this waterfall over time? Okay. Now, if you see carefully the picture, we can see how a waterfall can shape the landslide. For example, the waterfall retreats, okay, the water come, and down in here. This is soft rock, this is hard rock, and this is undercutting step side gorge. In here, the overhang collapse. Why? For the force of the water. They plunge full, and the pebble stones and boulders. Okay? You can see it in here. The water come with force down, make the force in here also, and continue in here. Okay, people. Let's see who says. No, I can't. Let's see. Here. Here. Let's see. No, I can't. Sorry. Okay, people. For the next hour, okay, we were going to have 10 minutes. for the next hour, we're going to work in the book. So everybody must have to get the book. And I will say the pages we are going to work in the next class. So see you in approximately 10 minutes, at 10 o'clock, okay? Bye.